Hello everyone, welcome to Reactify Labs. Um I know that this video is coming after a really long time, and I apologize for that. Uh, I, 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 I was not getting enough time to make videos apart from my daily work and some other new commitments that I have. So I'll try to be continuous from this point onwards. So let's break the pause with one lead code question. Okay. So after this, I will keep making lead code design LLD HLD videos one by one, and I will try to be continuous. At least try to upload one video each week. Okay. So let's see what we can achieve. So the problem that we are going to discuss today is two keys keyboard. So the problem statement says that there is a keyboard which has only two keys. Okay. And those are the same two keys which we as software developers use a lot in our daily life. One is copy, one is paste, right? Basically we use three keys, CTRL and then C or V. Okay. So basically the same thing, copy and paste. And it says that there is a letter A on the screen, okay, which is present by default. Now the problem statement is that you are provided with a number n. It means whatever the value of n is, you have to print this A that many number of times. So let's say n is 3, you have to print A 3 times, correct? But you don't have to print it. You have to say that uh, how many of these operations will you need to conduct to get this desired value. So let me explain in more detail. The problem statement says you can only copy and paste. And unlike our daily life where we can choose how much to copy, so for example, let's say our sentence or word is this much long, we can choose to copy only this much, or we can choose to copy only this much, right? But this problem statement says that you have to copy the entire thing, entire sentence. Whatever is on the screen right now, you have to print everything. And paste is you can do pasting of last operation. So if the last copy you have done is this, you will have to paste this. Okay. And let's say again, without copying, you paste again, you will again paste the same thing which you have copied the last. Okay. You can paste as many times as you like. But the problem statement says that what is the minimum number of times you need to do these operations so that you can achieve those many number of times that A should occur. For example, let's say initially A is already there. Okay. A is already there. Now it says that you have to print it 3 times. So to print A 3 times, you have to do it A, right? So what will you do? You will do first, you will copy this A, right? So you copy. Okay. Copying happens of this A and then you paste. So once you paste, this A becomes A and A, right? Next, if you copy again and paste, this will become AA, 4 times A. You don't want this, right? So you will instead just paste. Okay. After this, you will again just paste. So you have already copied this, and after that you have not copied anything. So this is the top element of your stack. So if you paste again, it will be AAA. So this is like the first operation is copy, and when you paste it, it becomes this. Second operation is paste, third operation is paste. So the output is 3. So you need 3 operations to print A 3 times. Next input is 1. Okay. So next input is 1. So A is already present one time. So you don't need to do anything else to make it print one time. So that's why the answer is 0. The answer is 3 for this. Next, let's talk about this. 4. So if A is present here, you can do first, you have to make it 2 times A, right? So I will write copy as C and paste as P. So you will first copy this A and paste. So what happens is when you copy A, and when you paste, it becomes AA, right? So once you copy paste, it becomes AA. Now from here you have two options. You can either paste again Okay, so when you paste again, it becomes AAA, and when you paste again, it becomes AAAA. Instead, what you can do is you can copy again. So if you copy, now your stack has double A, and when you paste, it will be double A, and after that your pasted thing will become double A. So if you see, both these approaches take four steps: C, P, 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 copy, paste, 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 or copy, paste, right? So it does not matter which approach you follow. It's just that you should do the minimum number of operations, right? Why minimum? Because let's say tomorrow somebody asks you to print it 100 times. You cannot just do C, P, 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 P up to 199 times, right? This is not right. Instead, you should try to do it in as minimum number of times as possible, correct? So let's see how you can solve this. So this question seems very tricky at first, because if you try to copy and paste it, you will have to think that, oh, how can I achieve what I want? Let's say we need to print 10 times, right? We need to print 10 times. So you don't know yet that, okay, if A has to be printed 10 times, what should you do? Should you make it 2 times AA and then copy it and paste 5 times? Copy and paste 4 times this? Or should you make it 5 times A first and then copy and paste 1 time? Paste 1 time, right? Both these approaches will give you 10 times A, but you don't know which one will have the least number of operations, right? It is easier to compare this time because you can see it, visualize it. But what if it is like 1,000 times, 10,000 times? You won't know, right? So that's why we will come up with a strategy which is easy and which will work for all of these things, or all the any number, right? So let me tell you one thing which I observed while solving this question. What I observed is, let's say first you have A, correct? Now you have to make it A. Let's make it A first. And you know that it requires 2 operations, correct? Now anything from this 2, you can make anything, right? You can copy paste it 2 times, so anything of size 4 can become. You can make it of size 6, you can make it of size 8, you can make it of size 10, like anything you can make, right? Now let's say you have to make something of size 9, then what will you do? From here you will make A. Then since this size is 3, now you know that 9 can be made from 3, right? You can paste copy 3 times, right? You can make it. So basically when you have AAA, you copy and then you paste it 2 times, it becomes 9. Or when you have AA, you copy and you paste it 1 time, it becomes 6, right? Or from here you copy and paste 2 times, it becomes 6. So you observe this thing, that if we can find out something, let's say if the number n, if there is number n and it can be made by multiplying A, B and C, there is some relation that we can derive from this. But before that, we have to observe one more thing. One more thing that we have to observe is this. If let's say we have n as 7, okay? Now from 1A, you made 2 A's, right? But from 2A, whatever you do, let's say what you can do is 2A, you copy 2A, then you paste it, right? It becomes 4A. You paste it again, it becomes 6A. But now if you paste it again, it becomes 8A, right? You cannot do it. You cannot now copy 1A. So instead, what you have to do is that you cannot copy it again. So it will be always like for 7 times A, you will copy it once and make it A 1, 2, 3, 4, 5, 6 times. You will paste it after this. So you will do C, P, but after that you cannot do C again. You have to do P. You can try it for any prime number, So currently I am discussing the case of only prime numbers. Any prime number you take, let's say 11. Again, if you have let's say 2 A's or 3 A's, you copy it, you make it 6a, you make it 9a, but after that you have no way to make again 2a's, right? You have to paste again 3a, because you have to copy everything on the screen, or you have to paste the last copied thing, and the last copied thing is 3a's. If you try it with 2a, it will be like 2a, 4a, 6a, 8a, 10a, but next will be 12a, because you cannot go back and copy a single a, because you have already copied double a's, right? So this is the problem here. So what we observe here is, if there is any prime number, the only solution is you copy a single a when it was single, and you just paste it n minus 1 times, right? So basically, if n is 11, you copy it once, single a is present, you copy it once and paste it 10 times, paste 10 times. So single copy operation and remaining 10 paste operations, to total 11 operations. So if n is prime, basically, let me write it again. I hope this is clear for the case of prime. Okay. So if n is prime, then answer is single copy one time plus paste n minus 1 times, right? So 1 plus n minus 1 is n. It means if n is prime, then answer is n always. So for any input, if you see for 3, the answer is 3. For 17, the answer is 17. For 97, the answer is 97. Okay. Now we have, these things. These are clear. This is clear because if n is 1, it will always be 0, right? Similarly for n is 2, because 2 is also a prime. 1 is not a prime. 2 is also a prime. So for 2, the answer is 2. Now we have to find for only composite numbers. Okay. So what we did was, we broke down the problem into two things. First for prime, second for composite. So we know the answer for prime now. Now we will find the answer for composite. So if you observe one thing again, for composite, let's take the example of a composite. Let's take the example of number 100. Okay. We know that any composite number is made up of prime numbers, correct? Prime numbers. Any composite number is made up of prime numbers by multiplying prime numbers, any number. For example, this 100 is made up of 5, 5, 2 and 2, right? This is all of these are prime numbers, correct? Similarly, 10 is 5 and 2, correct? 25 is 5 and 5. Any number you take, any composite number you take, it is a product of prime numbers. Okay. Now let's see one thing. Let's try forming the numbers. So this 100 says this is 5 into 5 into 2 into 2. So if we have a single a, if we can make double a, right? We have one step closer. Now from double a, if we can do something like, what do you say? 4 a's, right? 4 a's, correct? And from here, is there a way? Is there a way to make this 100? Yes. So if you do this, like if you copy this 4a, because 4 is now divisible by, like 100 is divisible by 4. So now if you copy this and paste, how many times? 24 times. It will give you 24 plus 1, 25. So from here you will take 25 attempts. But from here to here you had to take 2 attempts. From here to here you had to take 2 attempts. So this will be 29. But the question is it the optimal answer? Might not be. But what can we do now? We can try some other thing. From A, we can make 5 A's, right? This will take how many attempts? Single copy and 4 pastes. So 5 attempts, right? 1 time we copy, 4 time we paste. And as I told you, since it is a prime, because 5 is a prime, so the answer is directly prime. For 5 input, the output is 5 because 5 is prime. Next is, you have to make 25 from this. If you have to make 25, again you will do single copy and paste 4 times. Why 4 times? Because if you do single copy, it will be 5 times A. 4 times paste means you will have 20 times, and 5 times is already present. So it is, again, this is 5 and this will have 25 A. 25 A's. You have this. Now since you have 25 A's, if you do one copy and one paste, you will have 50 A's. And again, if you do one copy and one paste, you will have 100 A's. Correct? And if you see, there is a relation. From here to here, it takes 2 attempts. From here to here, it takes 2 attempts. Here it took 5, here it took 5. So basically, total number of attempts is 5 plus 5 plus 2 plus 2, which is 14. Again, which is basically the sum of these numbers. So the answer for composite numbers is break the composite number into the product of its primes and add the prime numbers. Let's take any other example. Let's take the example of 100. I don't remember what the constraint of this problem was. I think it was 1000. Okay. So let's take the example of n equals to 1000. Let's break 1000 into prime numbers. So we know that 1000 is 10 into 100. We just broke down 100 into 5 into 5 into 2 into 2, and 10 is again 5 into 2. So the answer for this should be 5 to 7, 17 and 4, 21. The sum of all the primes. Sum of all the primes, the product of which make up n, right? This is the answer. Take any number. Let's say we take the example of 4. So 4 is basically 2 into 2, and 2 is a prime number. So 2 takes 2 attempts and plus 2. So the answer is 4. Correct? So the answer for 4 is 4. If you see, here we have our answer, right? So now we know for prime as well as composite. So basically, if I have to tell you how to write the code or the pseudo code, it will be just like, if just handle the base case. If n is 1, then you return 0. And for other numbers, for prime numbers, it will be like while n is like greater than 1, you just keep iterating it, like again do a loop and find which numbers are divisible, which numbers are dividing n basically, and whatever the number, if that number is prime, number is dividing n and is prime, just add that number to the answer plus equal to that number, right? And once your entire loop ends, you can just return the answer, right? So this is something interesting. This is actually an interesting problem which forces you to think critically, which forces you to analyze different outputs for different inputs and come up with an approach, right? So I really like this problem. I encourage all of you to try this without looking at the solution. Now already you know the solution. I should have said this before starting explaining the solution, that you should try this on your own first. And I'm pretty sure since you have come here, you must have tried it yourself. So all the best. We will meet again in other video. Till then, bye, and please like, share and subscribe. Yeah, we'll meet again soon. Thank you.